In today's video, we're going to go over potential energy, and then I'm going to walk you through an MCAT question. As usual, I don't like to throw MCAT physics equations at you and have you just memorize them. I want to walk you through everyday scenarios that are intuitive to understand so that we can build the equation together. That way you don't have to rely at all on memorization, and you really just have this intuitive understanding of the equation and the relationships between the variables, because that is what's important for the MCAT. Because let's face it, there are hundreds of equations you need to know for the MCAT, and if you're just relying on rote memorization, you're doing yourself a massive disservice. All right, let's get started. Before we get started, if you haven't yet subscribed, be sure to like, subscribe, and hit that notification bell to stay up to date with all of my content. Also, share this video with your friends. It really helps the channel grow, and I would really appreciate it. In this video, we're going to be discussing potential energy. We're going to have a separate video on kinetic energy, and then finally one on conservation of energy, where we combine the two concepts with one another. Okay, so potential energy is nothing but the energy stored within an object due to some external force having the potential to act on it. So this marker is set to have potential energy because while I'm holding it up here, the gravity has the potential to act on it. So as soon as I let it go, it'll start to move, and that's because gravity is acting on it. So let's think about the variables that will impact, increase, or decrease potential energy. The first thing that comes to mind is probably force. I just mentioned force, right? But specifically mass, right? So if I were to ask you, would you rather that I drop this marker on your head versus a 50 kilogram dumbbell? I think most of us would choose the marker, right? Because the dumbbell will crush your skull. So that probably implies that it has more energy stored within it. And that's indeed the first variable in the potential energy equation. So U equals mass. By the way, if you're wondering why we denote potential energy as U, that's because both P and E are already taken by other variables within physics. So that's why we use U. Notice that over here, U and mass are on different sides of the equation, and they're both in the numerator. When you see variables on different sides of the equation, and both in the numerator or both in the denominator, then they are said to have a direct relationship. So if you increase mass, potential energy will also increase. All right, now let's think about the next variable or the next factor that will likely impact potential energy. If I were to ask you, would you rather that I drop an egg on your head from this height or from the height of Burj Khalifa, which one do you think most people will go with? I think most people will go with this height, right? Because dropping it from the top of Burj Khalifa is probably going to do more damage. So the next factor that impacts potential energy is height. And also notice, both in the numerator, opposite sides of the equal sign, so they have a direct relationship with one another. There's one more factor that's maybe a bit less intuitive. If we were to carry a 50 kilogram dumbbell on Earth and drop it, versus if we were to go on the moon and drop the same 50 kilogram dumbbell, which one do you think stores more energy? Well, since we know that Earth is a bigger celestial body compared to the moon, then that means it has more gravitational force to pull on objects, right, versus the moon. And that translates to a higher potential energy on Earth versus the moon. So the final variable we're going to discuss is gravity. And indeed, the potential energy equation is mass times gravity times height. Now, before we move on and do a realistic MCAT question, we're going to talk about the units very quickly. On the MCAT, you'll typically see potential energy expressed in units of joules or kilojoules, but they can also use the individual units of the variables over here. So we know that mass is in units of kilograms, gravity is in units of meters per second squared, and finally height is in units of meters. So we end up with kilogram meter squared per second squared. So that is what a joule is equivalent to. So you can also choose answer choices that use this expression for potential energy. The question reads, a 20 kilogram rock is dropped from a 20-meter cliff on Earth. Ignoring air resistance, what's the rock's gravitational energy just before it is released? All right, so I always like to draw a quick diagram to make sure that I am conceptualizing things correctly. Now, some of you might think this is a straightforward question, and it is a bit of a straightforward question just because we're taking into account just potential energy. But as you'll see, when we tie potential energy with kinetic energy, the problems get a bit more difficult and a bit more realistic to what you'll see on the MCAT. So notice over here we said on Earth, so that means the gravitational force is going to be 9.8 meters per second squared, but I'm going to round up to 10 to make things easier for myself, and you can do this on the MCAT with no problem. So let's plug in chug over here. Potential energy equals the mass, which is 2, the height, which is 20, and the gravitational acceleration, which is 10. So 2 times 20 times 10 is equal to 400. Notice our closest answer over here is answer choice D, 392. And on the MCAT, you don't have to be exact because the numbers will be far apart from one another to the point where you don't have to be exact and you'll still get the answer correct. All right, if you found this video helpful, be sure to like and subscribe to stay up to date with all of my content. Love you all, and I'll see you in the next one.